Now we are seeing problem from engineering mechanics and from the topic centroid. So if you see the problem, determine the centroid for shaded portion. So this is the one area is given. So for this shaded area or shaded portion, we have to find out the centroid location of the centroid, that is x bar and y bar locations. So if you see, this is a not regular shape, it is a complex shape. So if you see this complex shape is made by regular figures, that is semicircle, triangle. So why we are discussing this means we have centroid formulas for regular figures, that is circle, semicircle, triangle, square, rectangle. For that we have direct formulas, or directly we can locate. But this is a complex or compound figure. For this we have to locate centroid, means we have the formula, that is a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3 by x bar, that is for x bar. And for y bar we have a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. So but that will do all plus when you want, when you are adding all the elements of the complex shape. But here, to this figure is made up of first of all three, or this area will get by this three simple figures, that is triangle. If you divide here like this, suppose if you see here, if you divide like this is a triangle, it is a rectangle, and it is a semicircle. So this total figure or total area we get by adding triangle area plus rectangle area. From that we have to remove semicircle area. So for that reason we will get here minus in this formula. So anyway, so to solve this kind of complex figure, we have to use that x bar and y bar formulas. So before that we require x1, x2, x3, y1, y2, y3. So let us locate this here, x1, x2, x3 and y1, y2, y3 in this figure. So here if you see, let us take, here we'll drop a line, perpendicular line here, such that this will become triangle. This is a area 1, and this rectangle will take area 2. So total rectangle, that is total 120 by 100 rectangle will take, means including this semicircle also, not removing. So total rectangle will take, and after that we will take this semicircle as a area 3. So here first of all x1, if you see, so this is a triangle. For this triangle, if you look at centroid or from centroid formulas, so suppose this is a base, this is a height, so this x bar will be one third of b. Suppose if you take this b, and this is h, breadth and height. So x bar is from this side, it is one third of b, but we are calculating x1 or x. So in this figure, so it will become x1. So it is from this side. So why we have taken this y-axis and why we are counting this side means, so first of all we are keeping this total area in a coordinate system, or in the first quadrant we are keeping this area. So why? Because we require x bar and y bar. So to locate this centroid of this figure, we require some reference. So such that we are drawing, or we are taking y and x axis, such that, and also we have to take y and x axis such that all the values we should get positive. So such that I am taking y axis from this last point and x axis from this bottom. So we locate all x1, x2, x3 and y1, y2, y3 and also x bar, y bar from this reference axis. So we have taken like this y and x axis for that purpose. So here if you see this triangle, so we want to get x1 here. So from this y axis we have to represent. So why? Because all this x1, x2, x3 and x bar will measure from this y, such that all will get positive, and all y1, y2, y3 and y bar will measure from this bottom, that is from this x. So if you take so this x1 will be 2/3 of b. So why? Because from here it is 1/3 of b, means so from here to here it is 2/3 of b. So that is 2/3 of b is, this is 80. If you see this diagram, this is 100. Suppose here also, if you see here, we have taken line here, like this. So this is total 120, means it is 80 20, so means from here to here it is a 100. So definitely if you draw a line, this gap will be 20, means so the width of this triangle will be 80, and height is 100 given in the question. Height is 100, so here also height is 100 here, so height of the triangle is 100. So anyway, 2/3 of b means 80 here, to 2/3 of 80, it is the x1 value, and x2 value, x2 is the location of centroid of the second figure. So that is the total rectangle 120 by 100 rectangle from this y-axis. So that is the x2 value. So x2 value from the figure we can write that so this is 80, we have calculated anyway, and here it is given 80 also, or we can say this is 100 up to from here to here 100, and this is exactly the center of this semicircle. This x2 means this location. So from here to here 100, from this diagram you can say 100, and this is total is 80 given. So 100, this is 80, means half of this we require up to here only. So this is the half of 80, that is radius of this semicircle. So that is 40. So from here to here 40, and from here to here 100 given in the question. So the total distance will become here 100 from here to here plus 40, 140. That is the x2 value, or you can say this 120 means half is 60, and it is 80 we have calculated. So that is 80 plus 60, 140. So anyway it is x2 value is 140, and x3 also will be on the same line. If you see this diagram, observe this diagram, or you can say this is the x bar of this semicircle if you take separately. So this is total 80, means x bar will be d by 2, that is 80 by 2, 40. So this is 40 and this is 100, 140. So anyway you can say that x2 and x3 are same, that is 140 and 140. So that is the x1, x2, x3 values. And if you write y1, y2, y3, so first of all y1 is the distance of centroid of this triangle from this x-axis we have taken. So this distance is y1. So this is h by 3, total is h, and if you take this is h by 3, that we'll know from the standard formulas. So h by 3 means h is 100 here, 100 given in the question, this is 100 given. So 1/3 of h, that is 1/3 of 100 mm, that is y1 value. And if you see y2, that is a distance of center or centroid of the second rectangle, second figure, that is rectangle from this x-axis. So total is 100 given. So this is 50, half of that. So that is 50. So here we are taking total rectangle, including this semicircle also, we are not removing this. So for this total rectangle, so the y bar, or here y2 will become half of this, means 100 means half means 50. And next y3, now we are taking separately semicircle of dimensions 80, and if it is 80, so this is the radius, so that is 40. And so if you take separately, so y3, suppose if you take separately it is y bar, and in the figure it is y3. So anyway, so this we know from the semicircle formula, this y bar is nothing but 4r by 3 pi, and here it will become y3. So you will write that formula 4r by 3 pi. So 4r is 40, because this diameter is 80, so r radius 40 by 3 pi mm. So we have got all this x1, x2, x3, y1, y2, y3. Next we have to find out areas also here. So a1 is the area of the first figure, that is a triangle here. If you see area of this triangle, that is this thing. So the base is 80 and height is 100. So we know area of the triangle formula as half into base into height. Half into base is 80, height is 100. So if you simplify that, we are getting a1, that is area of this triangle as a 4000 mm square. A2 area of rectangle here, this rectangle. So it is given 120 and 100. So we have taken 120, 100, that is a rectangle. So area 2, That is area of the second figure is 120 into 100, 100, that is 12,000 mm square, and A3 area of this semicircle. So pi r square is the circle area. So semicircle means pi r square by 2. So pi into r value 40 square by 2. So we are getting it as 2513.2741 mm square. So we got areas also, and substitute the formulas of x bar and y bar to get that values. So we know x bar formula, it is a1 x1 plus a2 x2. So here, so what we are doing means we are just adding these two figures, areas of these two figures. So in this x bar formula, a1 x1 plus a2 x2 total rectangle, and from that we are removing this semicircle. So that we can write formula as a1 x1 plus a2 x2 minus a3 x3. That is because to get this shaded area, this semicircle area must be removed, such that we are removing that. So we can write formula as minus a3 x3 by a1 plus a2 minus a3. That is a semicircle's area. So a1 4000 we got, and x1 2/3 of 80 plus a2 12,000 140, and substitute this a3 and x3 values, and a1 a2 a3 values, and if you simplify that, we are getting x bar value as 114.3 140 sorry 114.3 mm. And next, y bar formula a1 y1 plus a2 y2 minus a3 y3 by a1 plus a2 minus a3. Here also same thing, this 1 and 2. So 1 and 2 we are adding, and we are removing this 3, because this is shaded area. To get, we have to remove this semicircle. So we can write formula, that is a1 y1 plus a2 y2 minus a3 y3 by a1 plus a2 minus a3. So substitute all this a1 a2 and y1 y2 values, and here also a1 a2 a3 values, and if you simplify that, we are getting y bar as 51.21 mm. So x bar we got 114.3 mm and y bar 51.21 mm. So this is the these are the coordinates of x bar and y bar, or these are the values of x bar and y bar for this shaded area. So for more videos, please subscribe and activate bell symbol. Please like it, share it with your friends, and don't forget to subscribe. Thanks for watching.